Fall pattern change to bring big heat wave to the east and severe storms to the central U.S. Hello everybody, it's meteorologist Jacob Campbell here with your WeatherNow forecast. So today we're going to be talking about the heat wave that's going on in the east starting today actually, and then the increased chances of severe storms that it'll bring in the central areas, and then the near average temperatures and even below average temperatures out here for the west. So without further ado, let's get into it. Actually, before we get into it, if you could like and subscribe this video, if you enjoyed, that would be wonderful. I greatly appreciate it. So now getting into it, we have this jet stream here that's stretching down into the south, the southern like California area, that will then stretch to the north over the Rocky Mountains and then pretty much stay to the north of the U.S., which is going to bring this dome of heat and humidity that's going to be coming out of the Gulf of Mexico for much of the eastern portion of the United States. Now, what this means is that you're going to see temperatures well above average in places like Wisconsin, Iowa, Missouri, Arkansas, Louisiana, and pretty much to the east. And then if you're to the west of that, you will see slightly to moderately above average temperatures. Then if you live on the west side and the north side of this jet stream, what's happening is this is channeling down air from Canada and Alaska, which is going to bring your temperatures down near average or even below average for the Washington State, Oregon, parts of Northern California, Nevada, Iowa, and Montana here. So another thing that's going to happen is we are going to get just all of this humidity that's being pulled into the eastern portion of the United States, and humid air, air that has a lot of water molecules in it, is actually lighter than dry air because water molecules are very light. They're 1 oxygen and 2 hydrogen, whereas oxygen molecules are in the troposphere at least, and through most of the atmosphere, there are 2 oxygen molecules bonded together. Oxygen is much heavier than hydrogen, and so you have, and also nitrogen is heavier than hydrogen, N2 is heavier than water vapor, and O2 is heavier than N2 and water vapor. And so you get areas that are really humid. They are much more buoyant. They like to float because they're lighter than the surrounding air. So they will begin to rise, and that's part of the calculation that goes into determining CAPE, convective available potential energy. The more moisture that you have, the more potential energy you have for convection. So what we're going to see here is we're going to see an uptick in really the pop-up storms all throughout the east, but especially out here in the Great Plains area where you have an increased threat for severe weather, mostly because of not only that humidity, but because the jet stream is pushing so far to the south. It's going to proceed off to the east. It will bring some relief as a low pressure system kind of builds, which you'll see in some a little bit later in the video. But a low pressure system is going to bring some cool air behind it, but because the jet stream is going to lift back to the north again, it's just going to continue bringing those warm and humid conditions. And so within the next couple weeks, it's going to be very warm and humid in the east, and there is a larger threat for severe weather over the next 2 weeks for the Great Plains. So what's causing this jet stream to go to the south? So during the summertime, in the summer months, the jet stream usually remains north because the jet stream is a product of a heating and cooling gradient from north to south. So hot areas give their heat off to cool areas, and so because of that, you have wind that begins to pick up from south to north. And because the earth is rotating, you get curvature in that wind. So instead of going from south to north, it begins turning and going west to east. And then at the point where there's the most energy transfer, that is usually the point where you get your jet streams at. So in the summertime, there's a lot more heat in the near the equator in the south, and a lot less cool like temperatures in the north, which pushes that jet stream much further to the north, well above the United States into Canada, And so we sit here with warm temperatures for much of the United States. Now, the reason why severe storms don't happen, even though we tend to be more humid and warmer in the summertime, is because we don't have that jet stream, which provides us it provides us a means to tilt the updrafts in thunderstorms to help produce long-lived storms. Another role that the jet stream plays in severe storm development is it also provides a very nice wind shear, so an upper air profile where wind speed and direction changes with height. You need that wind speed, obviously, like I said earlier, for the tilted updraft, but you also need a change in height, change in direction with height in order to get you need to get, it helps you get rotation in thunderstorms causing mesocyclones. So those are the pivotal roles that the jet stream plays, and because it's to the north in the summertime, we don't get very many severe storms during the summer. But during the spring and fall, when the total energy in the south is declining and the poles are getting colder, the jet stream pushes to the south again and starts to destabilize, which causes some more severe thunderstorms in the plains and in the Midwest. So, without further ado, we're going to come over here and take a look at the 500 millibar winds. So you see here, this is the jet stream that I'm talking about. It stretches down here through Southern California and then lifts up to the north. Another thing that happens is, if you notice, there are a lot more greens to the west or to the east of the Rockies than there are to the west of the Rockies. The Rocky Mountains actually help accelerate the jet stream, and so with an accelerated jet stream, you get even higher chances of severe weather. Unlike hurricanes, severe storms on the main continent actually thrive on wind shear. So we're going to progress this forward, and now here is one of the biggest areas that we're going to be looking at. This is Thursday. So you see that jet stream kind of deteriorates and it pushes off to the north and then pushes to the south here, staying well to the north for much of the eastern United States. But this is called a shortwave trough. And so what you have with a shortwave trough is you have a kind of a kink in the jet stream, and it pushes further to the south, and you see accelerated winds. And so with those accelerated winds, once again, you get increased chances for severe thunderstorm activity because it does help push that the updrafts in the storm over, creating longer lived and more severe thunderstorms. So progressing in, you do see that this even moves further to the east and then affects some of the Great Lakes, and so we could see some severe weather in there as well. It's going to stay well to the north of the majority of the United States. Oh, and that system that I'm talking about right here, this is the low pressure system that will bring some cooler temperatures temporarily in right behind the cold front in the cold sector of the low pressure. But that jet stream stays well to the north, and then it begins to progress down again, moving into the beginning of next week. And so this is when we could see severe thunderstorm activity once again, because we have another shortwave trough progressing over the Great Plains and even into Texas, Oklahoma, and Kansas. So looking now at Cape, as I said, we've got the reason why there's so much Cape here in the south, the southern United States, in the Atlantic, and in the Gulf of Mexico is because you have primarily moist air masses over those areas, which it's just so conducive to updraft and to convection that you have much more of that potential energy there than on the mainland, where you don't have a whole lot of moisture, but you may have quite a bit of surface heating. You just don't have that moisture that you really need. So we're going to progress in, and you do see that there are areas here, especially in Nebraska and Iowa, that have a large amount of Cape in response to this jet stream moving to the north and bringing a lot of that moisture in. And that Cape pretty much is just going to kind of sit in this area. It'll move away with systems, but it keeps replacing itself, just really driving home the point that there's a lot of potential severe activity that's going to happen in this area. We're going to take a look now at dew points. So this is actually dew point anomalies. So the higher, the more red you are, the higher the dew point compared to average. And then the more blue and green you are, the lower of a dew point you have compared to average. So the less moisture you have in the air versus with the reds and whatnot, the more moisture you have in the air compared to normal. So as we see with all of that just moist air channeling in, we do have some extremely high dew points compared to normal in the Wisconsin, Iowa, Illinois area right now. And actually what's going on right now is there is a system moving through that could bring severe weather to this area, which I've got my eye on. And so that's largely because of these higher dew points. And so you'll see that for majority of this central U.S. until this low pressure system sets up here, the dew point anomalies are just crazy high. And so that low pressure will bring some drier air from Canada in the back end of it. And it's going to push off to the north, but it's replaced almost immediately by those high dew points again for at least until the 20th of September, which is as far as the European model goes. We're going to take a look at the temperature anomalies. And so we do see in the Great Lakes area, the Ohio River Valley, and for parts of the southeast, we do have it's only a few degrees above average. We're talking 1 or 2 degrees above average when this model was run. But you will see that we start to get, not only is that temperature anomaly widespread, but it also will intensify in the coming days, as we'll see in the model. And the West will primarily remain cooler because they are to the north of the jet stream, so you do have the Canadian air coming in, which will help cool things down. But it's just going to be very, very warm for the eastern U.S. And here's that low pressure system that I was talking about. In the cold sector of the storm, you do have some cooler than normal temperatures, but that quickly dissipates and then is replaced with all of the warm air that we are seeing in the south. So I hope that you all enjoyed the video. Please be sure to like, comment, and subscribe, and I hope that you all have a wonderful day. Thank you and have a great day.